So in this example, we want to identify the key features of the quadratic function that's given to us. So here we have our parabola for the quadratic function, and let's see if we can identify the key features. So the vertex, the turning point of your parabola, that's happening at 2, -1. X-intercepts are happening at 1, 0, and 3, 0. A y-intercept is occurring at 0, 3. Our axis symmetry goes through the vertex, and that's going to be at x = 2. Concavity, we can see that the parabola is opening up. And our domain, there's no restrictions on our inputs. We can say -infinity to +infinity. Our range, the lowest our outputs are going are from -1, and they continue on to +infinity. What could be a possible equation? Well, remember, the equations come from the x-intercepts. So if I know the x values for the x-intercepts, I can get the factors for my equation. So if I see I've got x-intercepts at 1 and 3, I can think, okay, well, x = 1 and x = 3. Originally, we take the factors and set them equal to 0. So could I make a 0 with each of the equations I have here? So remember, if it's a 1, it came from the other side. So if it's a positive, so think of it as addition, subtract. Positive addition happens, so you undo that by subtraction. We now have the factors needed for our equation, x - 1 and x - 3. So when we go to put our possible equation, we're going to have y =, we'll have some value for a. Now the question is, should a be positive or should a be negative? You have to look at the concavity of your graph. Because this is concave up, the a value should be positive. So we need some kind of positive a value, and then we can write the factors for our function, x - 1 and x - 3. So this would be a possible equation, again, a being positive, and if you want to put a positive sign in front of a, you're welcome to do that, times x - 1 times x - 3. All right, so let's see if we can do something along similar lines. If the vertex of a parabola is at -4, 3, could you sketch more points to complete the graph? So thinking about what you know about parabolas, could you plot a few more points to complete the graph, and then talk about the key features of the x and y intercepts, axis symmetry, concavity, domain, and range? Well, we know that parabolas, quadratic functions, have symmetry around the vertex, right? That's why we've got our axis of symmetry. If the vertex is at -4, 3, and you envision that line of symmetry going through here at x = -4, we should be able to plot mirror images of the points given to us. And then we can complete the curve for our graph. Now, we can see about x-intercepts, our function is not going to touch the x-axis, so we don't have any in this case, and that's okay. We're not always going to have x-intercepts or y-intercepts depending on our function. Now for us, a y-intercept, we know that the input should be of 0. What output would we need? And visually, as we look at our graph, it's going to cross eventually at some point, and we're not sure. Because we don't have an equation right now, and we can't get an equation with what we know so far with just basing it off of the x-intercepts, the factors, we know one exists, but we can't complete it, so we're just going to say, well, one exists, if we have an input of 0, we're just not sure what that output is at this point, and that's okay. Again, we use that axis symmetry to help draw our parabola, so we know that x is equal to -4. We also know that it's concave up. Talking about domain, there are no restrictions for the inputs. And for the range, again, we want to go from lowest to highest. Well, the lowest we can go is 3, and there are no restrictions to how high. Therefore, our range would be bracket 3 to +infinity. And so now you're going to continue practicing these techniques with your practice problems following.